Share Beirut presents Ayah Bdeir, Little Bits.
Great. I have to follow Jill, bringing human rights to Zimbabwe, and I'm the capitalist coming to talk to you about her toys. No judgment. No, but seriously, I want to say to Corinne and Jill, and particularly Corinne, I'm a very, very big fan of Nasawiya. I'm a huge fan of what you do. What we've been complaining about for many, many years, you guys are actually doing, so I think they deserve another round of applause. So I'm here to talk about something very different. I'm here to talk about something that I've been working on for many years that has evolved very much over the past years. Some of you may know about it, and it's called Little Bits. Oh, are we going? Okay. I spotted some of you here that were with me in school. I did computer engineering here in AUB. This was the first electronics project we did in class. It was the Z80 processor. It was a course that we took over 2 semesters, a processor that already was obsolete by the time that we started learning it. It was very obscure, very difficult. We didn't understand anything we were doing for the 2 months that we were working on it, and it was the way we learned electronics. And for me, I realized that from that first course, I realized I hated electronics. For the first year in engineering, I decided I wanted to leave it. But I stuck with it, and I stayed, and throughout I started to think, what is the reason that I hated electronics so much? It was the way that we were taught. What is the absolute opposite way that you could learn about electronics? I started thinking about things that were inspiring, material that you learned how to play with, popsicle sticks, pipe cleaners, Lego, things that you grab, that you play with, that are as far away from chips and resistors and capacitors and electronics as you could be. And started to really think about what are the aspects of it that make it so difficult, and realized that what I needed to work on was to really make electronics an actual material. So I started to create these little cardboard pieces and wanted to mimic sort of a very iterative behavior of playing with material, swapping them, putting them together, iterating on them, trying again. Really the opposite of what you do from when you work with electronics. You buy a piece of electronic, it's finished, it's in a box. If it breaks, you often don't know how to fix it, and you throw it out and buy a next one. So really starting to break that and turn it on its head. And throughout time, it took 3.5 years, I started developing a library of electronics called Little Bits. It's a library of open source electronics that's snapped together with magnets, and the purpose is to get kids, designers, artists, adults really, to start to play and be creative with electronics. So the first key was it to be modular. And it went from this was the very first prototype, which was really these very simple cardboard pieces, to having electronic circuits soldered, embedded, kind of very ugly and very rough, to a few years later becoming what I'm going to show you right now. So I realized that one of the things I really hated about engineering is that engineering was not social. We were the rejects of AUB. We were the ones all the way at the bottom. We were the ones that were rumored not to have any friends or a social life, and actually for the 4 years we were. But more than that, when we studied, engineering was very isolated. You studied by yourself. We did it sometime with friends, and you would share homework and previews, but it was for the most part isolated and very elitist. And for me, I really wanted to make engineering social. I wanted to make it fun. I wanted to help people share it. So one of the really important parts about Little Bit is that it's a library. It's a library where every single module has one function. One function: light, sound, sensors, motors, switches. And as the more the library gets extensive, the more it becomes powerful. And the idea is that it's open source. People can add to it. People can download the design files. They can make them themselves. We went from having, when I first started, there were 3 modules. There was a battery, a switch, and a button. Actually, I'm going to show them to you right here. I have them here if anybody wants to see. So like you see, they just snap together with magnets. And so the idea was that, we had battery, switches, and lights, and now we've added hundreds of others. We have 45 products that we've already started selling, and we have people that suggest new bits, and they keep growing. We've been manufacturing, we started in New York, we've been manufacturing in the US and abroad. Things have been going really well. We won a bunch of awards, and really the nicest thing that I've been hearing is that people from the toy industry who have been working in toys for the longest time, who are depressed and hate the toy industry, come and say, you know what, what is wrong with the toy industry is exactly what you're trying to change, is that toys are made to break, and they are made to be thrown away, and they are made to be obsolete. And this is something that I think is really bad, and it's really making kids take that for granted. You can see some of the bits that we have. They're divided into input, output, power, and wire. And the coolest part about it is that we start getting images, pictures from parents when their kids start playing with electronics. Kids as young as 2 and 3 and 4 and 5 and 6, and the parents themselves say, we're not techie, we hate technology, this is not for us, we're illiterate. A few seconds after they start playing with them, they start to get very comfortable. These are some of the pictures that parents have sent us. Kids that are younger, just sort of pushing buttons, seeing what happens. Some kids that are older start to understand what's happening. And then some really older kids that actually, turns out, are also actually have a nostalgic feel to electronics because this is how they used to be. This is actually my favorite, sleeping with it. So one thing I mentioned is that a little bit is open source. It's a very counterintuitive thing to do with electronics. I know a lot of you are fans of open source software, and I think that's wonderful. I'm a very big fan of that as well, and trying to do it for hardware. It's not very intuitive for hardware because there's an actual material cost to hardware, to manufacturing, to shipping it, to transferring it. But open source for us is very important. So the design files are available online, and we have tons of people that look them up, learn from them, add to them, and suggest. And I think ultimately this will be the way that we start to create more relevant products. We start to create things that scale and build upon each other and are not each made to fail and made to be thrown away. We also start to do these workshops where we treat electronics as if it's any other material. We put them on a table. You have lights and sounds and switches, and you also have cardboard and paper and felt and scissors and glue, and you put them all together and you tell people, make something. And turns out people come up with some pretty cool stuff. This is one of the first projects that we made. It's called Light Wheels. It has little balsa wood with 2 motors in the front and the back, a light sensor, and when you shine a light on it, the car starts to follow the light. This is another project that's one of my favorites that we did that we had one workshop participant make.
Go. Okay, my name is Katya Bravo, and I made a skyscraper and a lighthouse.
So how does it work?
So what it does is that it jingles and it blinks the light, and this is how it works. Cool, huh?
Wow. Did you like playing with Little Bit?
Yep.
You did?
What she said is that she made a Chrysler building that jingles and dances. And so there's a little pressure sensor, there's a pulse module, there's some LEDs, a vibration motor, and a Christmas bell. She did it all by herself. The only help she got was from her mom when she was cutting the Chrysler building. Workshops are actually my favorite part because when we give the material, we give sort of a 5-second demo to people, and people really surprise us. This is one of my favorites as well. Was done in a workshop at NYU. Oops, sorry. That's it, very simple. I really like it because it was a new type of mechanism that we hadn't seen before. And then this is also fun. This is sort of coming back to the idea of making electronics social. You know, making games that are not assigned to you, prescribed to you, where you have to behave in a certain way. This is a game that 2 students at NYU made themselves.
Can you do another shot?
Yeah.
How did you call your project?
How did we?
Whoa!
Keeps hitting the woodwork.
Oh, nice!
Yeah. That's the first save. Yeah, first save, exactly. And we got.
This is a project that actually was cool. There's a DC motor in the in the propeller. It's turning. There's a fan on the other side of the circuit. When you press the pressure sensor, it blows a foam ball. And the goal of the game is to get the ball kicked off by the propeller. It was a project that they did in 45 minutes in between workshops. And actually, from that, we got a lot. And these were art students that in the beginning of the workshop said, you know what, we're just going to watch. We don't think we could do this. And at the end of it, they had made their own game, and they were very excited. One of the things I also get really excited about is a page on the site we have called Dream Bits, where people put ideas of bits that they would like to see made. Some of them feasible, some of them not very feasible. You know, photovoltaic power bit, photo relay alarm, but some that you don't have here, actually a fart alarm, or a penguin finder, or an alarm to keep my sister out of my room. So things that are very relevant and become very exciting. And I mean, this is the beginning of the journey, and obviously we don't know where this is going to go, so it's exciting. So I would encourage you, if you're excited about something you do, which you feel other people don't understand, to try to find a way to make them understand where lies your passion. Try to communicate it. Try to turn things around that you learned, and I think there's a lot that we can do. Thank you very much.